Now, I can't recreate exactly what happened in the simulations run by the various groups, but in terms of predicting the results, I can get pretty darn close, if you did your simulations correctly, that is. If you messed up in the steps of the simulation, it's kind of like messing up in the steps of a chem lab. You aren't going to get the correct outcome. In group one, the unconditional cooperator had, and I am certain of this, an average payoff of 0 gold coins. So its fitness is 0. Sorry, whoever you are. While the average payoff for the unconditional defectors will be something like 1.61. In group 2, the unconditional defector won big. Their average payoff was 5 gold coins exactly. And the fitness for the unconditional cooperators should be around or about 2.54. How close am I here? In group 3, the tit for tat players should have a fitness of something less than 1, about 0.82, while the unconditional effectors would have a fitness quite a bit greater than 1, maybe something in the ballpark of 1.68. Now in group 4, the lone unconditional defector's fitness should be around 1.69 or so, while the fitness of the tit for tat players will be roughly 2.23. Now I'm giving you these numbers on the outside chance that one of your groups might have gone somewhat astray with their simulation. Usually I'm around to keep an eye on what's going on in the groups so I can steer them straight when things start getting off track. If your group's results are dramatically different from what I'm giving here, it's probably because of a misunderstanding of the instructions. The first thing I want you to be able to do is to use your understanding of the simulation we ran and how it was set up and the strategies that were in play, and be able to explain why these results make sense. If you were in group 1, you know exactly why the poor old cooperator got demolished while everyone else did better. You lived it. But if you were in any of the other groups, can you see why the fitness of the defector strategy should be what it is, something greater than 1, but not by too much? The way you should be thinking here is that in this group, the unconditional cooperator would be receiving a 0 payoff each time. That part is easy enough, right? But the unconditional effectors would be getting a payoff of 5 every time they interacted with the cooperator, which is about 1/6 or 1/7 the time, depending on how many students we had to put in that group. And they would be getting a payoff of 1 coin in all the other interactions, which would be defector on defector. Now, the average for a handful of interactions with payoffs of 5 and a whole bunch of interactions with a payoff of 1 comes to definitely a number greater than 1, right? You should be able to apply this kind of thinking to understand what went on in each of the groups. When you look at the groups 3 and 4, you'll need to take into account the way that tit for tat will change its interaction with a defector once it's been burned by that particular defector. Now, you have been a guinea pig in this lab experiment, that's for sure. But each of you guinea pigs also needs to take ownership of these results in the role of experimenter as well. Got it? Okay, now that's the first thing. The second thing we need to address is the phenomenon of frequency dependent versus frequency independent natural selection. Recall from the first video that the fitnesses that we're recording in our class results can be used to project the direction of evolution for these populations based on the directional natural selection as dictated by the relative fitnesses for the two strategies. In group 1, the fitness of the unconditional cooperation is 0, while the average fitness for the unconditional defector is greater than 0, 1 point something. Who has a higher fitness? Should unconditional cooperation be more abundant or less abundant in the next generation? Easy enough, right? So, for the first question in the IPD lab worksheet, that's the second page in the Google Doc that you should have in your virtual hands right now. Project the direction of evolution for each of the four groups based on the fitnesses that you're seeing in the results table that I'm showing in this video, because I can't guarantee ahead of time that the student results for our actual class are going to be accurate, at least by the time you get to this video. For each of the groups, identify which strategy increases and which strategy decreases. Okay, now the thing to notice here is that in two of the groups, you're seeing the same strategy favored, irrespective of their original frequency in the population. Unconditional defection is favored over unconditional cooperation when it is common and also when it is rare. It doesn't matter what the frequency is. In other words, it is frequency independent. You don't need a crystal ball to tell you what's in store for a population that starts off with any number of cooperators and defectors. Defection will increase, and then it will increase again and again and again until you get to the ultimate outcome of pure unconditional defection. Put this into the terms of our invasion schema that we used in the first video. If you had an island where everyone was an unconditional defector, would a small number of unconditional cooperators be able to invade? Which of our four groups' results supports your answer? Now, if you had an island where everyone was an unconditional cooperator, would a small number of unconditional defectors be able to invade? Which of the four groups' results shows this? See, if it's just a matter of unconditional cooperation versus unconditional defection, our original dilemma, as stated in the classic prisoner's dilemma, is not changed. The phenomenon of cooperation has no chance against defection, and there's no opportunity for systems to evolve toward greater levels of cooperative behavior. Now let's do the same kind of analysis for groups 3 and 4. Unconditional defection is favored over tit for tat when it is common, but it loses to tit for tat when it's rare. See that? You get qualitatively different directions of evolutionary change depending on which strategy is more common. This is frequency dependence. Take a moment to let this result sink in. Now, if you're asked to predict what's going to happen if a population has some number of tit for tat and the rest unconditional effectors, you'll need more information to make the call, right? If the defectors are rare, you would predict higher fitness for tit for tat. But if tit for tat is rare, then you would predict that unconditional defection would win. So for the next question set in this worksheet, answer this. If you had an island where everyone was an unconditional effector, would a small number of tit for tat players be able to invade? Which of our four groups' results supports your answer? If you had an island where everyone was a tit for tat player, would a small number of unconditional defectors be able to invade? Which of the four group results shows this? So one novel result here is that the tit for tat island is one in which the cooperative behavior rules, right? Everyone is cooperating with each other. It's the island of love because no one ever makes that first defection. In this regard, this island would be indistinguishable from an island made up of entirely unconditional cooperators. The difference is that the tit for tat island would be protected against invasion by malign players, or at least those that show themselves as malign players by defecting unconditionally. Remember that the island of unconditional cooperators would be invaded and completely run over by the unconditional defectors. So this model is actually giving us one means by which a cooperative society could have some ingrained protection against a more defecting invader. Okay, so the first thing was that you can understand the results of the class as an owner of the experiment. You are not just a guinea pig. The second thing was how things shifted from frequency independent to frequency dependent by switching out unconditional cooperation and switching in tit for tat. And you can also see how this plays out in terms of making it possible for unconditional defection to at least not win all of the damn time. Now, the third thing about these results is that you can see that two of the four groups, are actually doing much better on average relative to the other two groups. Which two have the higher average fitnesses? Yeah, now why do they have higher fitnesses? Well, in groups 1 and 3, the predominant interaction was mutual defection, with each player taking away one gold coin. In groups 2 and 4, the predominant interaction was mutual cooperation. And hence, the fact that the average fitnesses for 1 and 3 are both closer to 1 and the average fitnesses for 2 and 4 are both closer to 3 should come as no surprise to any of us. Could these differences contribute to an increased ability of cooperative behaviors to evolve? Good question. The answer is yes, but only if we introduce the concept of a meta-population, which for our purposes here is a population of populations. Many local groups of individuals, and the collection of all such groups is the meta-population. Let's put them on distinct islands. Each island has its own local group of individuals that can be either unconditional cooperator or unconditional defector. Let's forget about the existence of tit for tat for this demonstration. I want you to see how this could happen to allow even unconditional cooperation to increase against unconditional defection. We already know that if you were to swap out unconditional cooperation and swap in tit for tat, this would only make things easier. So if we were to start out with at least some of these islands consisting of purely unconditional cooperators, call these C islands. They would have average fitnesses 3 times higher than what you would have on the purely D islands. More success, faster population growth, larger and more robust populations. Okay, now let's say a hurricane rips through and causes massive destruction. The stronger populations of the C islands are less likely to be wiped out, right? And the C populations will generally be sending out more migrants that can colonize the other islands, some of which are the ones left vacant by local extinction of the D population. See where this is going? Now, the hurricane in this scenario basically set up a form of group level selection that allowed the fitness differences between C islands and D islands to result in an overall increase of C and a decrease of D, even though it still remains perfectly true that if you ever had C and D on the same island, D would win every time. So, to see that this meta-population scenario offers one more potential means by which cooperation can increase against defection. Okay? It's also abundantly clear that in the absence of the meta-population structure, in other words, if we just had one big old population with C and D, you would never be able to have C increasing overall. This means that the opportunity for cooperation to increase is an emergent property of the metapopulation structure. By the way, this narrative is actually one that was first proposed by Sewell Wright, one of those 3 credited for making the original Darwin-Mendel synthetic theory of evolution. For the third and final item for you to address in your worksheet, I want you to evaluate the class data set. What's going on with your results? Does it look like all of the groups have their acts together? If you see any discrepancies, what were they? And could you suggest a possible explanation for how they arose? This is the last of the lab activities that will be included as fair game for the first exam. But in next week's lab, we will be giving up a small portion of our meeting time to have volunteers solve the three practice Hardy-Weinberg problems that I've posted on Canvas. Please consider putting together a solution onto a sheet that can be screen shared on Zoom. Be sure to include a natural selection scenario and a non-random mating scenario. That is, if you are finding any departure from the Hardy-Weinberg expectations.